We grew up believing that time is the most reliable thing in the universe. You can lose your keys, miss a train, forget a name, but time always marches forward. Breakfast comes before lunch. Causes come before effects. That belief feels so solid that we never think to test it, and that's exactly why it's dangerous. Here's where intuition quietly betrays us. If you go faster, you expect to arrive sooner. Simple. But when speeds get close to light, sooner stops meaning what you think it means. Two people can watch the same event and disagree about which thing happened first, and both can be right. That's not philosophy, that's physics. Now imagine pushing past the light barrier, not just going very fast, but faster than light itself. Suddenly, the universe doesn't just get weird, it starts arguing with itself. Effects can show up before causes. Messages can arrive before they're sent. The future starts leaking into the past. And at that point, the real question isn't, can we time travel? It's why does the universe seem to forbid it so fiercely? Here's the first misconception, and it's a very natural one. We think time is obvious. We think it's the one thing in the universe nobody could possibly disagree about. You might argue about politics or music or who left the dishes in the sink, but not about what happened first. Now, let me gently poke at that confidence. Imagine you see lightning flash in the distance. A few seconds later, you hear the thunder. You don't say, "Ah, the thunder happened later." You know the sound just took longer to reach you. You already accept that information travels at a limited speed. So here's the quiet question hiding in plain sight. If information takes time to reach you, how do you know when something really happened? That question feels a little uncomfortable, doesn't it? We usually dodge it by saying, well, it happened when it happened. But that answer only works if everyone can agree on when that was. And already, without doing anything exotic, we've found a crack. The reason time feels simple isn't because it is simple. It's because we live slow lives, surrounded by signals that move so fast we barely notice the delay. Our intuition is tuned for bicycles and conversations, not for the deep structure of reality. And that's important, because when we start pushing speed, really pushing it, time stops behaving like a polite, straight road, and starts acting like something much stranger. Now let's push a little further, using something very familiar. Think about walking down a street with a friend. You're side by side. Left is left, right is right. Everything makes sense. Now your friend turns around and walks backward. Suddenly, your left is their right. Nothing about the street changed, but the description did. Time works more like that than we'd like to admit. Most people imagine time as a straight road painted onto the universe. Past behind us, future ahead, and everyone agrees which way is forward. That's the common misconception. We don't just use that picture, we trust it. Now let me gently break it. Imagine two people far apart, each with a stopwatch. A flash of light goes off somewhere between them. One person sees it first, the other sees it later. They try to decide when it happened. They exchange messages, correct for delays, argue politely, and eventually agree, as long as nobody's moving very fast. But now suppose one of them is zooming by on a fast train. Here's the surprise. When they do the same careful accounting, they may no longer agree on which event happened first, not because someone made a mistake, not because clocks are broken, but because time itself is tangled up with motion. That's a hard thing to swallow. We're very comfortable with the idea that speed changes where you are. We're much less comfortable with the idea that speed changes when things happen. Our brains resist that because nothing in daily life prepares us for it. We like to imagine that if we slowed everything down and watched carefully enough, there would be a clean, universal order underneath. But nature doesn't promise that. Here's a simple way to feel the discomfort. Suppose I say, event A caused event B. You nod. That feels safe. But now imagine someone else, moving differently, says, no, B happened before A. Your instinct is to say one of you must be wrong. But what if neither is? This is where our thinking habits get us into trouble. We treat time like a background stage, solid, fixed, unquestionable. But it turns out time behaves more like a relationship between events than a ruler nailed to the wall. And once you accept that, once you let go of the idea that time is a straight, universal road, you're standing at the edge of something strange. Because if motion can tilt time, then extreme motion might flip it. And that's when faster than light enters the story. Now, let's bring speed into the picture. Not science fiction speed, just speed you already understand. You've felt this before. You're in a car on the highway, everything moving smoothly, and then another car zips past you. For a moment, it feels strange, like you slowed down instead of them speeding up. Nothing actually happened to time, of course, but your sense of motion shifted. That feeling is a tiny hint of what's coming. Most people think speed is only about how fast you get somewhere. Faster means sooner, slower means later. Time itself, they assume, stays politely in the background, ticking away at the same rate for everyone. That's the misconception. Now imagine two people with clocks. One stands still. The other hops onto a very fast train. As the train speeds up, something unexpected happens. Each person sees the other's clock ticking more slowly. That already sounds wrong. How can both be right? Here's the surprise. You don't need anything mystical or fancy. It's just the way information arrives. Each person is using signals to observe the other, and motion changes how those signals line up in time. The universe isn't doing anything dramatic. Our expectations are. This is where intuition starts to sweat. We're used to thinking that if two people disagree, one must be mistaken. But in this case, the disagreement isn't an error, it's a feature. Time isn't keeping score the way we thought it was. Now let's gently push the speed higher. As motion increases, the disagreement about timing grows. Events that look nicely ordered from one viewpoint start to look squeezed together or spread apart from another. Before and after begin to loosen their grip. And here's the quiet warning sign. If speed can stretch time enough, it might eventually twist it so far that order itself becomes negotiable. We don't notice this in daily life because nothing around us moves anywhere near that fast. Our brains evolved for walking, running, maybe throwing a spear, not for objects chasing beams of light. So, intuition works until it suddenly doesn't. Think of intuition as a map that's excellent for your neighborhood and useless at the poles. It's not wrong, it's just out of its depth. So by the time we reach truly extreme speeds, time is already behaving less like a straight line and more like a flexible fabric that different observers tug in different directions. And now comes the dangerous question. What happens if you keep pulling? What happens if you push speed all the way to the limit and then try to go beyond it? Now we're going to step onto slightly slippery ground, but don't worry, we'll go slowly. Think about something very ordinary again. You ask a question, then you wait for the answer. If someone answers before you finish asking, you'd be startled, but you'd probably assume they guessed or you spoke too slowly. You would not assume the universe had broken. That's because we rely very heavily on one quiet rule. Causes come before effects. We don't usually notice how deeply this rule is woven into our thinking. We don't say, the window broke because the ball hit it earlier. We say, the ball hit it, so it broke. Order matters. It's how explanations work. Now let's try a little imagination experiment. Suppose you're on a very fast spaceship. You send a message to a friend far away. Did you receive this? And before you finish blinking, you get a reply. Yes, and by the way, don't send it. That should make your stomach tighten a bit, because now you have a puzzle. If they already received your message, and they're telling you not to send it, what happens if you listen to them? Do you send it or not? And if you don't send it, how did they receive it in the first place? This isn't science fiction drama, it's a logical knot. Here's the surprising part. Once things move faster than light, situations like this don't require special tricks. They pop out naturally from the way time behaves for different observers. From your point of view, everything feels sensible. From their point of view, everything also feels sensible. It's the combined story that stops making sense. And that's important. Human thinking assumes there's always a single, global story everyone can agree on. One timeline, one order. One, what really happened. But nature doesn't promise that, especially when speeds get extreme. We evolved in a world where nothing outruns light, so our intuition quietly assumes it never will. That assumption works beautifully until you challenge it, and they still disagree. Here's the surprise. Neither one is wrong. Their disagreement isn't about opinion, it's about motion. Each person is moving differently, so the way time lines events up is different for each of them. There is no master clock hiding behind the scenes to settle the argument. That's uncomfortable. We humans love referees. We want a final answer. We want the universe to tap the chalkboard and say, this happened first, end of discussion. But at high speeds, the universe refuses. Now here's where faster-than-light travel becomes dangerous. As long as nothing outruns light, disagreements about order stay mild. They don't cause trouble. No one sees an effect happen before its cause in a way that matters. But the moment you allow faster-than-light signals, these disagreements explode into contradictions. One observer sees you send a message, then receive a reply. Another observer, moving differently, sees the reply arrive before the message was sent, and both descriptions are internally consistent. That's the key point. This isn't a glitch. It's built into how time behaves. Our intuition collapses here because we secretly assume time is a single list of events, written in ink. But time behaves more like a set of notebooks, each observer keeping their own, all valid, none absolute. And here's the real danger. If faster-than-light motion exists, these notebooks can contradict each other in ways that destroy cause and effect entirely. We didn't notice this flaw earlier because nothing in our world moves fast enough to expose it. Nature has been protecting us from our own bad assumptions. So the problem with faster-than-light travel isn't just speed. It's that it allows perfectly reasonable observers to tell stories about the universe that cannot all be true at once. And when reality can't agree with itself, something has to give. In the next part, we'll see just how badly things can flip when time doesn't just disagree, but turns around and runs backward. All right, now we've arrived at the point where things stop being merely odd and start becoming truly unsettling. Up to now, time has been stretched, tilted, and disagreed about, but it's still moving in roughly the same direction. Causes mostly come before effect. We can argue, but the universe hasn't contradicted itself outright. Now imagine pushing speed just a little further. Suppose you have a magic signal, nothing fancy, just something that can travel faster than light. You send it from one place to another. From your point of view, it behaves perfectly sensibly. You send it, it arrives, end of story. But here's the catch. Someone else, moving differently from you, looks at the same situation and sees something shocking. They see the signal arrive before it was sent. Not delayed, not reordered by accident, genuinely reversed. This is the moment where people usually say, that can't be right. And I sympathize. It feels deeply wrong. But the mathematics, and more importantly, the logic, doesn't care how it feels. Here's a simple way to picture it. Think of time like a stack of cards laid out on a table. Everyone walking slowly agrees on the order. But now imagine the table itself is tilted, and different people are walking around it from different angles. What looks like top to bottom to you can look like bottom to top to someone else. Faster-than-light travel doesn't just stretch the stack, it tips it far enough that the order flips. Now, here's the part that really matters. Once one person can see an effect happen before its cause, you can chain these viewpoints together. One observer sends a message. Another receives it early and sends a reply, also faster than light. From the first observer's perspective, the reply arrives before they ever sent the original message. No tricks, no cheating, just speed and perspective. And now we're in real trouble. Because this isn't about fancy time machines or science fiction drama. This is about the universe losing its ability to keep track of what depends on what. Prediction collapses. Explanation collapses. You can no longer say why something happened because the why might come later. Human intuition rebels here because we depend on order to think at all. We evolved in a world where nothing outruns light, so nature kindly hid this madness from us. So when people say, "What's the harm in going faster than light?" This is the harm. It doesn't just let you travel faster. It lets time turn around. And once time can run backward, even occasionally, the universe no longer makes sense in any language we know how to speak. Next, we'll see why the famous paradoxes, grandfathers, loops, contradictions aren't the real problem at all. Now, this is usually where someone raises their hand, real or imaginary, and says, "Ah, you mean the grandfather paradox. You know the one. You go back in time, do something unfortunate, and suddenly you're never born, so you couldn't have gone back in time, so, well, you see the mess." People love that story. It's dramatic. It makes for good movies, but it's actually a distraction. The grandfather paradox isn't the real problem. It's just a symptom. Let me give you a more ordinary example. You follow a recipe. Step 1, boil the water. Step 2, add the pasta. Now imagine a recipe where step 2 happens before step 1. You don't get a dramatic explosion, you just can't cook dinner. The instructions stop meaning anything. That's what faster-than-light time tricks do to the universe. Here's the common misconception. People think paradoxes are exotic accidents, rare, special cases you might be able to patch up with clever rules. But once faster-than-light travel is allowed, paradoxes aren't accidents. They're everywhere. They're built in. Try this thought experiment. You send a message that prevents itself from being sent. Not by killing anyone, just by saying, "Don't send this message." That's enough. You've already broken the idea of explanation. There's no consistent story left to tell. Now notice something important. Nothing magical happened. No swirling lights, no portals, just information arriving in the wrong order. Human thinking hates this because we rely on stories to understand the world. Every explanation we give, scientific or otherwise, depends on one thing leading to another. Take that away, and knowledge itself collapses. We're very tempted to say, well, maybe the universe somehow avoids the bad outcomes. But that's like saying a book avoids nonsense by rearranging its sentences while you're reading it. That's not understanding, that's hoping. The real issue is deeper. Faster-than-light motion breaks the idea that events can be consistently ordered for everyone. And without consistent order, you can't define cause, effect, explanation, or prediction. This is where intuition misleads us again. We think paradoxes are rare curiosities because we only meet them at the edges of imagination. But that's because nature has placed a speed limit that keeps us away from those edges. So the lesson isn't time travel causes weird stories. The lesson is the universe is built to prevent stories from breaking. And in the next part, we'll see something rather beautiful, how the universe enforces that rule, quietly, without drama, simply by refusing to let anything outrun light. Now here's a funny thing. We keep saying the speed of light, and that already puts the wrong picture in your head. It sounds like light is the star of the show, like some champion runner setting the pace for the universe. But light is just the messenger. It's not making the rules, it's obeying them. Think about traffic for a moment. When you see a speed limit sign on the road, you don't imagine the sign causes cars to slow down. The sign is just telling you something about the road, its curves, its traffic, its dangers. The limit comes from the structure of the situation. Same thing here. The universe has a built-in rule about how events can be connected, about how one thing can influence another. Light just happens to be the fastest thing that can carry information without breaking the bookkeeping. Here's a common misconception. People think the universe is being overly strict. Why not just let things go faster, as if nature were a grumpy bureaucrat? But it's the opposite. The limit is what keeps reality from falling apart into contradiction. Imagine a library where books rearrange themselves while you're reading them. The beginning changes after you reach the end. You wouldn't say, "What a mysterious library." You'd say, "This place doesn't work." That's what faster-than-light influence does to the universe. It doesn't make things exciting, it makes them meaningless. Now here's a small surprise. Even when things move close to this limit, very close, time already starts acting strangely. Different people disagree on how much time passed, on which clock ran slower. And yet, remarkably, everything still fits together. No paradoxes, no contradictions. It's tight, but it works. That tells you something important. The universe isn't fragile, it's precise. We humans like to imagine we can push ideas just a little further. What if we bend the rule? But some rules aren't bendable. They're not optional add-ons. They're part of the framework that lets any story be told at all. And this is where humility comes in. We didn't design time. We didn't vote on causality. We discovered them by noticing where our intuitions fail. So when physics says nothing goes faster than light, it's not scolding us. It's quietly saying, this is how reality stays consistent. And once you see that, time travel stops looking like a missed opportunity and starts looking like a clue. Because the really interesting question isn't how to break time. That's easy in imagination. The real question, the one we'll end with next, is why the universe is so carefully arranged that breaking time is impossible at all. Let me end this not with a bang, but with a pause. People often come to this topic hoping for a trick, a loophole, a clever way around the rules. Maybe someday they say, we'll figure out how to beat time. I understand the impulse. We've beaten a lot of things: distance, darkness, disease. Why not time? But here's the quiet lesson hiding underneath everything we've talked about. The universe isn't teasing us by forbidding faster-than-light travel. It's teaching us something about how deeply structure matters. We started with a simple idea. Time feels obvious. Then we discovered it isn't shared. Then we learned it depends on motion. Then we saw that pushing speed far enough makes cause and effect wobble and eventually flip. And finally, we realized that letting that happen doesn't make the universe more interesting, it makes it incoherent. That's the key point. Reality isn't a playground where anything that sounds fun should be possible. It's more like a language. Grammar matters. If you scramble words at random, you don't get poetry, you get noise. Faster-than-light influence is grammatical nonsense in the language of the universe. Here's a small human moment to think about. You've probably had a conversation where the order of words mattered a great deal. Change the order and the meaning collapses. Time is like that. It's not decoration, it's syntax. We humans are very good at imagining events. We're much worse at imagining consistency. We underestimate how much work the universe is doing just to make sure things don't contradict themselves. And that's why I find this whole story comforting rather than disappointing. It tells us that the universe isn't arbitrary, it isn't sloppy, it's careful. It allows incredible flexibility. Time can stretch, observers can disagree, clocks can fall out of sync, but it draws a firm line where meaning would break. We don't get time travel, but we get something better, a universe that makes sense deeply enough for science to exist at all. And the most Feynman-like lesson of all is this: when your intuition fails, don't panic, smile, because that's not the end of understanding. That's where it begins. Time isn't what you thought it was, and that's not a problem. That's an invitation to keep asking questions.